So this is an alpha decay problem. We're going to balance it. So how you balance it is that basically all the numbers on the bottom on this side have to equal the numbers on the bottom on this side, okay? And the numbers of top have to equal the numbers of top as well. So in this equation, we have the atomic number is 88 and the mass number is 222. So we take that, we take 222 over 88 Ra, which is the element, and then we know it yields a alpha particle plus something else. And to find that something else, we kind of use algebra, and we do 88 minus 2, which is 86, and then we do 222 minus 4, which is 218, and then we go to the to find the element, we go to the periodic table, and we find atomic number 88, or 86, and we find that it is this one, Rn. So then we write Rn here, and that is the balanced nuclear equation. Next is the beta equation. So we have carbon 14, which basically means that the mass number is 14, it's carbon, and to find out what carbon atomic number is, you just look on the periodic table and you see that it is 6. And so you put 6 on the bottom, and then it yields a beta particle, which is 0 over -1 beta, plus whatever the other one is. And we go back to the alpha particle one, where we use this, we minus this from 6 and minus that from 14 to get whatever we need to get. So 6 minus -1 is 7. 14 minus 0 is 14. So the, and then we go to the periodic table, we find out which element is 7, and that's nitrogen. So we put N, and that is another balanced equation. Okay, next one is, there's alpha decay and alpha emission. They both mean the same thing, but we're just going to go over it. So this is another written out one. It's uranium-235 decays by alpha emission and gamma ray emission. So what this means is that uranium weighs 235, and we have to go to the periodic table, and we have to find uranium, which is, let me find it. It is somewhere over here. It's a tricky little bugger. Oh God, where did it go? Oh, uranium does not have an R, it is just a U. Big mistake, I'm sorry. Uranium is 92. And that yields alpha emission, which we know is 4,2He, and a gamma ray, which is just 0, 0, and then the gamma ray symbol. And then we also have to find the element. And we go, it's just like the two problems that we did before. We add all of these together, which is just 4 over 2, because these are zeros. So we say 2 minus 92 is 90. 4 minus 235 is 231. 90 on the periodic table is TH, and that is yet another balanced equation. Okay, this is called positron emission, and this is the one where it's the electron. It's basically just like we did before. It's 2312 mg yields whatever that is, plus positron plus a gamma ray. So we have to do this minus this is this. So it would be 11 over 23 over 11. And 11 on the periodic table is sodium, Na. And that is another thing. It's called positron emission. That's what this is called. Another is electron capture, when the nucleus captures an electron to stabilize it. And it goes on this side because it's part of this now, whereas it's not part of this. So we do 81, 36, Kr, just like we do the other problems. And then we do the electron. And that yields, whatever that yields, plus a gamma ray. And because gamma rays are 0, you can't minus anything from this side, but you have to add these together. So 36 plus -1 is 35. 81, because that's a 0. 35 on the periodic table is Br. And those are how you balance different types of radioactive nuclear equations.